This is definitely a cool problem. I got this from MIT Integration B. Here it turns out you don't need to integrate. So what I'm going to do is to do change of variables first. A new variable y, which is equal to x minus pi over 2. Imagine the graph. I'm going to move the graph to the left. If y is x minus pi over 2, then say x is going to be y plus pi over 2, right? Now, when you do the change of variables, new boundaries are going to be from negative pi over 2 to pi over 2. That's because if you plug 0, you'll get negative pi over 2. If you plug this pi, you'll get pi over 2. Now the new boundaries are symmetric from negative pi over 2 to pi over 2. So, and then it's going to be cosine. Instead of x, I have y plus pi over 2 plus cosine y plus pi over 2. And dx. So since dx and dy, they are both linear, I can replace dx with dy. So that's not a big problem. At this point, we can use one simple reduction formula of trigonometry. So cosine, so here's the formula, cosine alpha plus pi over 2. So any number plus pi over 2 is going to be negative sine alpha, okay? So now using that formula, my expression becomes this one. So this has become negative sine y, right? Also note that this part also has pi over 2 one more time. So that's, if you take this as pi over 2 and the rest too as this alpha in this formula, what you will get here is reduced form, negative sine of y minus sine y dy. So this is new form of my integral. So why is this form is better than this one? So here is the thing. It turns out this function is an odd function. So what was odd function? When you plug negative number inside the odd function, you can just take that negative sign out of the function. So that was the odd function. Let's try to plug odd. So let's try to plug negative y into this function. So negative sine minus y minus sine minus y. So here we have this. So at this point, we know that sine is an odd function. So you can take this out, this negative sign. So take out this negative sign and take out this negative sign. They are together with this one. This will simplify to just sine of y minus sine y function. So this is an odd function. So that's very easy to verify using this formula. Now when you know that this function is an odd function and you are integrating it in a symmetric interval from negative pi over 2 to pi over 2, it means that this integral is equal to 0. That's it. You don't need to integrate the function. The only thing we did was to shift the function to the left and prove that it's an odd function. That makes the whole integral equal to 0.